Kubernetes is a powerful system used to automate the deployment, scaling, and management of containerized applications. It enables developers and operators to handle large applications by grouping containers into logical units called pods. This video series covers core concepts essential for interviews focusing on Kubernetes and container orchestration. A pod is the smallest deployable unit in Kubernetes. It represents one or more containers that share storage, network, and specifications for how to run the containers. Pods are ephemeral and always scheduled together on the same node. They provide a single Internet Protocol address which the containers inside share. Services in Kubernetes provide a way to expose applications running on a set of pods. There are four main types of services. Cluster IP service exposes the service on an internal cluster IP. Node port service opens a specific port on all nodes to allow external access. Load balancer service uses cloud provider load balancers for external access. External name service maps a Kubernetes service to an external DNS name. A service configuration in Kubernetes defines how applications communicate within the cluster. Selectors determine which pods the service targets. Ports define the communication ports, mapping external service ports to pod container ports. This stable configuration ensures reliable networking and automatic load balancing among pods. Deployments in Kubernetes allow declarative updates and management of pods and replica sets. They enable rolling updates, which means updating pods without downtime by gradually replacing them. Scaling can be done by specifying the number of replicas. Deployments also support easy rollback to previous versions and automatic self-healing by recreating failed pods. A deployment YAML file defines the desired state of the deployment. It specifies the number of replicas to run, a selector used to identify pods managed by the deployment, and a pod template that describes the containers, including their images. Deployment configurations are used to manage application lifecycle with ease. Ingress in Kubernetes manages external HTTP and HTTPS traffic to services within the cluster. It acts as a single entry point, allowing traffic routing based on URL paths or hostnames. Ingress supports SSL termination to encrypt traffic and provides load balancing across backend services, making it essential for managing web traffic. An ingress configuration specifies rules for routing. It requires an ingress controller to process these rules. You can define host-based or path-based routing, map requests to backend services, and configure TLS for secure communication. These configurations enable efficient management of external access to services. There are two primary types of scaling in Kubernetes. Horizontal scaling involves increasing or decreasing the number of pod replicas based on demand using tools like the horizontal pod autoscaler, which monitors resource usage such as CPU or memory. Vertical scaling adjusts the resource allocations like CPU and memory to individual pods, optimizing them for workload needs using the vertical pod autoscaler. Managing containerized applications in Kubernetes involves several key commands. Applying configuration files deploys or updates applications. Monitoring pod status and logs helps track application health. Scaling allows dynamic adjustment of application instances. Executing commands inside pods and deleting resources are essential for debugging and lifecycle management.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.